Hello, hello. We are going to continue talking about evaluating expressions, but today we're going to be talking about evaluating expressions with two or more variables. All right, so we're going to start off with one that I think you've seen before, potentially, but the classic food example. So, example one, we're going to start big with some Route 66. So Route 66 charges $4.95 for a burger and $1.95 for fries. How much do they charge for 5 burgers and 4 fries? So you're going to be given the expression. So we've got 4.95b plus 1.95f. And then you want to make sure, just double check that you know which variable represents what part of the word problem. So b is our variable, and it's right next to the coefficient of $4.95. So I'm assuming b means burger, but do burgers cost $4.95? $4.95 for a burger, so that makes sense. And then we know that we have 5 burgers. So that number 5 is going to go in place of the number of burgers. So there's some connections we need to make here. So 495 times the number of burgers, which is 5, plus we have another coefficient, $1.95, which is next to the f. So we have $1.95 here, represents the fries, and it's saying that we're getting 4 fries. So we want to put a 4 in parentheses instead of the f. And then we have a plus sign in between. We've got multiplication because a number is next to a parentheses, and more multiplication because a number is next to a parentheses. So if we look at order of operations, parentheses, nothing we can do inside the parentheses. The 4 and the 5 are the only things inside each parentheses. I don't see any exponents. Multiplication and division, I do have multiplication, so I can do 495 times 5, which gives me 2475. I'm not going to do my addition yet because I still have more multiplication, so I'm still on the multiplication and division step. So I multiply it here. I also need to multiply $1.95 times 4, which gives me 780. Now the only operation left, my bad, I put AA, should be AS for adding and subtracting. So last step, you add those two together. You get 2475 plus 780. It gives us 3255. So that is the correct math, but what does this number mean? So we would say it costs $32.55 for 4 fries and 5 burgers. So that is our final answer. Not only do we have the correct number, we did the correct math, but we know what that actually means. That is the total cost that we're going to be charged. This is obviously, we didn't put taxes in there, but this is what the subtotal is going to be at Route 66. Second example I want to talk about is some ice cream. So you may or may not have done this example before, but we got La Michoacana sells paletas for $2.25. And ice cream cones for $1.20, with each scoop costing $2. So we got $2.25 for paletas, we got $1.20 for the cones, and $2 for the scoop. So it might be a good idea to start making connections so that $2.25 refers to the paletas, the $1.20 refers to the cones, and the $2 refers to the scoop, so we know which one each of these is. So there's no question yet. Let's fill in the question here. How much does it cost for 23 paletas and 6 cones with 3 scoops each? So you could come up with this expression, but we're going to give this expression to you. We got 1.20x plus 2.00 y times x plus 2.25 z. So in this expression, it's not as easy as saying, oh, paletas, the variable should be p, cones, it should be c, and scoops, it should be s. We got to figure out, what does x represent, what does y represent, and what does z represent. So the way I would suggest doing this is just looking at what the connections we have up here. So it's 225 for a paleta. I only see a 225 right here, and it's next to z. So on top of paletas, I'm going to put a z, so I know that's the variable, or you could just put paletas, so you know that's what that variable represents. Next to 2, I have an x and a y, so I don't know which one is actually representing the scoops yet. So let's move on to cones. I see $1.20 next to x, $1.20, and it's cones. So x has got to represent cones. It's the only variable that's next to $1.20. So x represents the number of cones. This x is the number of cones as well. And our only variable that's left is y. So y must be the number of scoops. So we can go ahead and start filling in our information here. So $1.20. How many cones do we have? We've got 6. So 6 is going to go in place of x, plus 2. Y is the number of scoops. So if we have 3 scoops, that's going in, the 3 for scoops is going in place of y. We have x again. So we had x, which was cones, and it was 6. It's the same variable x, so it's the same value of 6. Plus 225, and instead of z, we're going to put in our number for paletas, and we have 23 paletas, so that is what we're going to put in place of z. So now we can go through and we can start simplifying Parentheses, there's nothing inside any of these parentheses that I can do, so I don't need to worry about that. Exponents, I don't have any, but I do have multiplication and division. Let's go left to right. So $1.20 times 6, that gives me $7.20. Carry down my plus sign. $2 times 3 gives me 6. Times 6 gives me 36. So 2 times 3 times 6, that gives me that 36. And then I need that 225 multiplied by 23, and I get 51.75. No more multiplication and division, so let's move on to addition and subtraction. So let me add all these together. 7.2 plus 36 plus 51.75 gives me 94.95. And then the last thing we want to do is make sure we have the context. So it costs $94.95 for 23 paletas, 6 cones with 3 scoops each. So hopefully the context should be pretty easy, because all you got to do is look at what question is it asking me, and instead of the question like how much, now that you know how much, you put in that value that you found and you just finish with the rest of the question. So that is our final answer, and that's how we evaluate expressions with more than one variable. Just make sure you're being careful about which variable is represented by each thing. Have a good day. See you later.